Hi, good evening. Welcome back once again. This is my third video in a day. It is currently just after 11:30 in the evening, and yeah, it's been a day. If you hear the puppies behind me, they are supposed to be sleeping, but much like little children, we know how that goes. All right, so this evening we're going to be finishing up with a presentation on markdowns and perishables. We are still in Unit 5, Merchandise Pricing and some Payroll for Math with Business Applications. Again, we're going to be covering today two topics with one or two subtopics. So I guess sort of 4 in all again, which is kind of our max out. This is from Chapter 8, Section 3. We're going to be looking at taking markdowns, doing multiple operations on pricing, and perishable items and how to figure items that basically spoil or go bad into our pricing, and how businesses deal with what's known as shrink. Shrink is theft or just loss in general. So our goals for this presentation are as follows. We want you to understand and explain the purpose of a markdown. Why do people take markdowns? What is a markdown and why do people take it? We want you to be able to calculate both the amount and the percent of a markdown. We want you to find the selling price of items, that is the sale price after a markdown is taken, otherwise known as the sale or discount price. We want you to be able to find the original price if you know the markdown amount and the markdown percent. So if I know that I took 10% off of something and that was $30, can you work your way back to what the original price was? And can you find the original price if the discount price and the markdown percent are known? So if I know I took 30% off and the resulting price is, let's say, $7, can you work that backwards to what the original price might have been? We also want you to be able to calculate the final sale price after a series of markups and markdowns. So we want you to find the original price of an item, and then we want you to go through a series of markdowns and possibly markups before we get to the final selling price. And once we have that, I might ask you a question or two. We want you to be able to explain and calculate the pricing for a perishable item or for an item that experiences shrink, which is just sort of a market term for loss of some kind. Could be theft, could be inventory, could be just a misplaced count in your inventory. So can you calculate that selling price for both a markup based on cost to begin with and a markup based on selling price? So what is a markdown? A markdown is a price reduction from the original selling price. So what we need to sort of get our heads around here is that what a business decides to originally post as a selling price of an item is not necessarily set in stone. It is always a temporary situation. Costs can change. Your need for certain amounts of profit or margin can change. So we shouldn't see a price reduction as a loss necessarily. Basically, anytime you're bringing money into the business, you're doing a good thing. And sometimes we need to mitigate our losses by making choices. And markdowns are a part of that. For example, we may have paid $15 for an item that we're selling in the store for $30, right? We've keystoned it. We paid $15, we're selling it for $30. If that item is not moving, if no one is buying it at $30, it's better that we reduce the price to $20 and get it off of our shelves and still make a little money than hold on to it at an inflated price that no one will pay. And that even extends to the idea that there may be times that even though we bought it for $15, if we can still sell it for $10, Bringing that $10 in, taking the loss on that one item is still more valuable to us. The $10 in hand is more valuable to us than $15 sitting on a shelf. Because if I can sell that for $10 and bring $10 into my bank account, into the business's bank account, that's one thing. But maybe even more importantly, that shelf space that $15 item is sitting on, I have just opened up to put something else there that could be more profitable, could sell faster and quicker, and could definitely make me more money, right? So we want to make sure that you don't see a markdown as a loss, that you see it as a potential for more sales, okay? Is that a little bit of spin? Of course. Of course that's a little bit of spin, but it is still better than $15 that nobody's buying sitting on your shelves, okay? You can cancel a markdown. This is just a phrasing that the textbook and in some in the industry use. When you cancel a markdown, that just means that the sale has concluded or ended, and your pricing on the item is going back to the last known price. So whatever the price was before the markdown is what your item is going to be when we talk about a cancellation, okay? Now, why do people take markdowns? I've given some of the reason for that. Usually it's because the original price is set too high. For whatever reason, your original pricing was too much. You over-anticipated or overly predicted. That's bad. You over-predicted what people would pay for that item. The second reason, or a second reason, is that maybe it's overstock. Maybe nobody needed that size or that color or that specific style. It could be that there are quality issues. So this may not even be something of movement, of taking it off of your shelves or of pricing it too high, but maybe there's a small nick in the bed frame, and so you can't sell it for $300. You're going to sell it as a scratch and dent for $200 rather, okay? It could be that there's seasonality. We all know where we're going to be on November 1st. So maybe I should ask this because that's my future, but it's probably your past. So where were you the day after Halloween? One of the best places to be is at the store to get candy. One of the best. All right. Calculating the amount of the markdown. Now, the markdown is another general equation. We know that the markdown has to equal the original price minus whatever the sale price is. What we have to keep in mind is that the original price, when we're talking about a markdown, is quite often just the last price. The last price that was listed. I'm sorry. I'm so sorry. This could be the original selling price of the item, or it could be the previously discounted selling price. It's just the last price. When we do a markdown, our original price or last price is our 100%. The markdown is listed as a percent of the original price, and we use the portion is equal to rate times base. In this case, the percent markdown is our rate, the dollar amount of the markdown is our portion, and our original price is the base. This is once again the triangle, the percent triangle that we've been doing the entire time, where P portion is the amount of the markdown, R rate is the percent of the markdown, and B base is the original price of the item. That means that those three formulas that we used in the first two presentations all apply here. The portion is the rate times the base. The rate is the portion over the base, and the base is the portion over the rate. It also means that we can use the chart. We have to modify it slightly. So instead of selling prices cost plus markup, I'm going to use the original price minus the markdown is the sale price. So our selling price is the original price minus the markdown. It's a variation on the very first equation that I gave you here. Markdown is the original price minus sale price. I've just swapped the spots of a markdown and sale price. I've just swapped them. So that the original price minus the markdown is the sale price. And this is our second sort of overreaching equation that we use in this section, right? Let's try a couple. A computer keyboard that originally sold for $86.29 was marked down to $52.99. What is the percent of the markdown? It says tenths there because I will take an answer to the nearest tenths. So we can use the chart and the proportions. 3 columns. The first column is our overarching equation. The original price minus the markdown is the sale price. Since this is a markdown, our base or 100% is the original price. So there's my 100. And then we're going to mine the word problem for the rest of the information. Data mining the word problem. So the original selling price was $86.29. It was marked down to $52.99. Now watch the way this is stated. It's marked down to $52.99. Not the markdown is $52.99, but it's marked down to a price of $52.99. So the $52.99 is actually the sale price. Be careful sometimes with the wording. And just so that I can put a plug in here, that's not a math problem. That's not a problem with mathematics. That's a problem with English. It's bigger than math. It's English and wording. I just take a little pressure off. Everything being blamed on the math class, just a little pressure off. All right. So if I know the original price is $86.29 and the sale price is $52.99, I can subtract those two, right? And I get a difference of $33.30. So $33.30 is the amount of the markdown, and I need to find the percent of the markdown. So my X goes in the percent markdown, and then I can put my little box over there. I can use those 4 pieces of information to set up a proportion that says 86.29 over 33.30 is equal to 100 over X. Cross multiplying, I get 86.29 is 3,330, and dividing both sides by 86.29, I get 38.590798, well, bunches of stuff, right? I only need tenths, so we're going to hold on to that. I think it's going to be 38.6, but let's just wait a minute and validate that. So I can also use the formulas, and since this is a formula and I'm looking for a percent, I'm going to use that the rate is equal to the portion over the base, where the rate is the percent of my markdown. The portion is the amount, the dollar sign, cha-ching on the markdown, and my original price is the base, which is the 100%. That's what it was supposed to be anyway. So the percent markdown is unknown to me. That's what I'm trying to find. The amount of the markdown I already figured out. That's the money saved, cha-ching, or $33.30. The original price is the $86.29. When I divide that out, I get 0.3859079885. Notice it's all the same numbers, right? But this is a rate, so it's a decimal. And to convert a decimal to a percent, I need to multiply by 100 to get my percent marked down. Move the decimal point 2 places to the right is the other way to think of that. And when I do that, I'm going to get a 38.59 or 38.6%. My percent markdown. Now, how do we find the original price or the sale price or the sale price? So we've already said that the sale price is the original price minus the markdown. Original price is our base. We know our markdown is going to be the rate times the original price. This is looking like what we've done already. So our sale price is technically 100% of the original price minus some markdown percent of the original price. Do you see the original price is in both of these pieces, right? It's in the 100% of the original price, and it's in the markdown percent of the original price. So I'm going to do what I did in the last 2 presentations, and I'm going to pull that original price out front. I'm basically going to undistribute it, if you remember the algebra section. And when I pull that out front, I'll be left with 100% on the original price and the markdown percent of the original price. I can put those in parentheses. So if I take the sale price, which is 100%, and I minus the markdown percent, in this case, the markdown is a percent of the original price. That means that there's like a common denominator there, so I can pull that original price out. I'm working in the same base, so I can pull that original price out, and the percents are subtracted to get the remaining portion. It's also worth mentioning that 100% minus the markdown percent is known as the complement of the markdown percent. Okay? So if I'm looking for the sale price, I can use the formula we've just developed here, that it's the original price times the complement of the markdown percent. Okay? Now, in order to get the original price, I'm going to take that complement, 100 minus the markdown percent, and I'm going to divide it on both sides. Now, on the left side, it's going to be in the denominator, and on the right side, it's going to disappear because I'm going to have 100 minus markdown percent over 100 minus markdown percent. So that means I have a second formula where the original price would be the sale price divided by 100% minus the markdown percent. Right? Let's try a couple of problems. Original cost of a tie is $27.50. After Father's Day, they're marked down 60%. What is the sale price of this tie? I have a problem about ties because I spent many a year waitressing at the Olive Garden in its original days when we had to purchase our own ties. I always bought my ties on sale because ties are expensive. You either get them, if you work in a place where you're going to get spaghetti sauce on your tie, you either buy them at the Salvation Army / Goodwill, which never has a whole bunch of them because everybody was trying to get them there, or you wait for Father's Day / Christmas and you purchase them on a deep clearance sale. They were some really ugly ties, but it's okay. You didn't want to pay more than $5 or $6 for a tie. You were going to get covered in spaghetti sauce. Okay, so the original cost of a tie was $27.50. After Father's Day, they're marked down 60%. What is the sale price of the tie? So we're going to use the chart and the proportions first of all. 3 columns. First column is our overreaching equation or sentence that the original price minus the markdown has to equal the sale price. Second column is our dollar amounts. Third column is our percentages. And because this is a markdown, the original price is going to be our 100%. Mining the question for the other information used to fill in. We're going to fill in as much as we can. We see that the original price was $27.50. They were marked down 60%. Not marked down to 60%, but marked down 60%. Means that 60% is going to be our markdown percent. When I know 2 of 3 in a column, I can find the third one. Following the sentence, I'll do 100% minus 60% is 40%. That's going to be our remaining sale price percent. And we have to find the sale price, so that's going to be our X. Looking at this as we have others, if I take the first row and the third row, I can use these 4 pieces to set up a proportion, which is 2750 over X is equal to 100 over 40. Cross multiplying, I have 100X is 1100, and that means that X is 11. If you would prefer the formulas, that would look something like this. From using the formulas, we know that our portion has to be the rate times the base. Our portion is the sale price. And the sale price formula is that it has to equal the original price times the complement of the markdown, or 2750 times 100% minus 60%, or 40% of 2750. 2750 times 0.4, 40% as a decimal, is going to be 0.4, which is $11 again. This lets me know that the sale price is absolutely $11 for that tie. I got to tell you, that would not have made the cut in my Olive Garden days. They always had to be like $5 or $6. All right. A lamp is marked 35% off and has a sale price of $48.50. What was the original price? Wording again, it's going to get us. So using the chart and the proportions, I know the original price minus the markdown has to equal the sale price. I know that the original price is my 100% because this is a markdown. Everything compares to the original price. I know that the lamp is marked 35% off, so the markdown is 35% off, and the sale price is $48.75. So $48.75 is my sale price, so that's going to go where the sale price is. Now, in the third column there, I have 135. I know that those two should be subtracted. That leaves me with 65% as the sale percent. So 65% is the same as the $48.75. I'm trying to find the original price, so that's my X value. The proportion is once again going to use the first row and the last row. When I do that, I have X over 48.75 is 100 over 65. Cross multiply. So 65X is 48.75 and X is $75. Using the formulas, we will again, or this time around, what we're looking for is the base because we're looking for the 100%. So we will have base is equal to portion over rate, where portion in this case is the sale price and the rate is the complement of the markdown. So we'll have the original price is equal to the sale price over the complement of the markdown, or 48.75 is over 100 minus 35, 48.75 over 65%, which is the same as 48.75 divided by 0.65, or $75. So whether you have used the chart or whether you've used the formulas, you should get the same answer that the original price is $75. As we end this sort of section where you can use the charts or you can use the formulas, I would just like to point out that for some people using the formulas will be really easy. I've included a lot of steps in the formula portion that most people would not use. But I do want to caution you that on this section in particular, when you have a missing base, and that happens a lot when we're doing these types of problems, it goes against your gut instinct for what's right. So in a lot of those cases, using the chart as a backup is a good thing to have in your pocket should you start to get confused about where stuff goes and what it is you're looking for. It's one of the reasons I like the chart best. All right. The next section is 8.11, and this is markups and markdowns in a series. Basically, there are two types of goods that we want to talk about. There are staple goods, and there are what are known as seasonal goods. Now, staple goods are basically items that everybody buys all year round. They don't generally undergo a lot of price fluctuations. These would be things like most of the staple food that we eat, tools, tires, furniture. I'm not saying that they never go on sale. Certainly, once again, around Father's Day and sometimes around Labor Day or Memorial Day weekends, tools will go on big sales because they go on sale when people can get out and do things. And living in Wisconsin, we probably see tires go on sale more often than somebody in, say, Florida. Just because as winter approaches, our tires can be a little bit seasonal. Furniture doesn't do much of sales. So, you know, that's probably a good example. Desks. This year, though, there might have been some. Seasonal goods are goods that can undergo a whole bunch of price fluctuations. An idea of these are strawberries, for example, comes to mind right away, right? There's a season for strawberries or apples or what else has a season? Sweaters, swimsuits. So fashion items, oftentimes equipment for outdoors like your lawn, the snowblower, etc. Holiday items around each and every holiday. We see soda, it comes to mind. My dad like Diet Pepsi-aholic. And so like Labor Day and 4th of July and Memorial, anytime there could be a party, like a grill out or cookout, soda goes on sale. And so we all like pitch in to buy extra soda so mom doesn't have to go out all the time and get more. But yeah, that's one. Soda's one. It's important to remember that an item can undergo a series of price changes and that you need to be careful about what numbers you're using. Again, the original price is what's listed in the formula, but that's not necessarily always going back to the first price. Original price just means the previous selling price. What was the price last time? Okay. All right. Here we go. We're going to try one. So a microwave cost the appliance shack $27 to purchase. They have a 55% markup based on selling price. And 2 months later, the microwave is marked down 20%. Then they're going to mark it up 30%. Then they're going to mark it down 40% before they clearance it at 25% off. And we're asking, what is the final selling price of this microwave? All right, the important piece to note here is that the selling price, they tell us, is a 55% markup based on selling price. Because they have a cost or markup based on selling price, we know that the selling price of the item is the cost divided by the complement of that selling price. Now, I'm using the formula here. You could just as easily draw a quick diagram and use the chart if you would rather. If we were going to use the chart, hold on, let me grab a pen here. I'm just going to put it up here. We'd have the cost plus the markup. Sorry, I'm writing it down, is equal to the selling price. This is how I would do it. We're going to compare the dollar amounts, and we're going to compare the percents. Okay, so this is me quickly writing this out. So if I was going to do this using the chart real quick, it's a markup based on selling price. So my 100 goes here with the selling price. The cost is $27. 55% markup base, so this is 55. So that's the information I've gotten from the problem. I know that because this is a markup, the cost plus the markup is the selling price. So 100 minus the 55 is 45. And I'm trying to find this, the selling price. So if I'm going to use a proportion, I'm going to look at the first row, which is filled in, and the third row, which is filled in, to write my proportion of 27 over x is going to have to equal 45 over 100. And I'm going to cross multiply that puppy and solve it for x. Okay? Now, many people are just going to go to the formula at this point because many people find it more efficient. I want you to get the problem right, so you use whichever method works best for you. Right? Our cost was 27. The complement of the markup based on selling price would be 45. So I'm going to do 27 divided by 45%, or 27 divided by 0.45, which is 60 bucks. Right? It's important that this part be correct. Because we're going to be doing a bunch of things in a row, if this calculation is wrong, every piece you do after this will also be incorrect. It can throw off your entire problem the rest of the way. So be very careful about this first calculation. All right? Pay attention to markup based on selling price and markup based on cost. Word of warning / pro tip. Okay. All right, so that's our first. We got a cost of $60 to start with. Now, 2 months later, the microwave was marked down 20%. If we're going to do a markdown of 20%, then what we need is the original price times the complement of the discount. So if we're getting a 20% discount, there will be 80% left on the price. 80% of $60 is 60 times 0.8 or $48. Then they're going to mark it up 30%. At this point, because it's in the middle of a series, we assume that it's up 30% from the last price. So we need $48, which was our last known price. We need to pay 100% of that and another 30% on top of it. So that's 48 times 1.3, which gives us $62.40. Notice that this markup does take us over the original price. That's fine. They're trying to get a little bit more money out of you. It's not a crime. It's just a buyer beware situation. However, in this case, it clearly didn't work because they have to mark it down 40%. And if they're going to mark it down 40%, that means that there is only 60% of that price left to pay. So we'll end up paying 60% of $62.40, which is $37.44. We are still above the cost. It's worth noting that we are still above cost. If they paid $27 for that microwave and they're now selling it for $37.44, they're still making money. Okay? But they need to clearance it, and they're going to clearance it at 25% off. If they're going to clearance that at 25% off, that means they're going to pay 75% of that $37.44. And to calculate 75% of $37.44, we take $37.44 times 0.75, which is $28.08. That gives us a final selling price of $28.08. That's only $1 over the cost, but it is still over the cost. Okay? And who knows how much money they made when they were selling them at actually $62.40. So they could have made up for any difference if they still sold a reasonable amount at $62.40. Having one or two left to clearance at $28.08 is not going to hurt them. They probably did not affect their margins at all. All right, I have a second example. And I'm just going to leave it here for a minute. I'm going to take a breath, and I'm going to let you, if you would like, just work this problem through, and then I am going to talk through it. So if you would like, take a pause, press pause, and come back to me in a minute. You can do it. All right. So in March, Home Depot purchases lawnmowers from the distributor for $69 each. Their original markup was 77% based on selling price. Again, look at that markup based on selling price. That is the most common type of markup for a customer-facing sale. In May, the lawnmowers were put on sale for 15% off. In June, there was a cancellation of that markdown. In September, the lawnmowers went on sale for 45% off. November has a final clearance with an additional 25% off again. What's the final selling price of the lawnmowers? So we're going to take our selling price, and since it is a markup based on selling price, we're going to take the cost and divide it by the complement of that 77%, which gives us $69 divided by 23%, or 69 divided by 0.23, which is $300 for a lawnmower. In May, they're put on sale for 15% off, so we need to go down 15% from that price. So we need to take off 15%, which is 85% of $300, or $255. 300 times 0.85 is $255. In June, they're going to cancel. Cancellation of a markdown just reverts to the previous price. So before it was $255, it was $300. So we're going to go back to the $300. And in all of June, and it looks like all of July, that lawnmower is going to be the original price of $300. Now in September, they're going to put the lawnmowers on sale for 45% off. At 45% off, that means they're paying 55% of that $300. 55% of $300 is $165. Yeah, $165. So from 165, in order to move the lawnmowers out, probably to make room for the snow blowers, we're going to take an additional 25% off. So that means they're going to have to pay 75%, but 75% of the $165. 75% of $165 is $123.75, which gives us a final selling price of $123.75. If I'm going to click for my answer, what do I want? I want arrow options. Nope, I don't. I need to come over here. All right, so I need to get rid of this pen. Get rid of that pen, and I'm just going to click this for an answer, and we can see $123.75 is what I knew it would be. All right, so we're going to take a look at perishable goods, perishable goods are goods that have no value out of a season or goods that spoil for some reason. We can also include in this formula items that experience shrink. Shrink refers to goods that are lost or stolen. Lost oftentimes refers to some sort of inventory error where we can't actually say that there was theft, but there could be a discrepancy, either major or minor. Our selling price in this case is based on the number of goods sold at the original price, but we want to adjust for the losses by taking what we expected to make and dividing it essentially by what we actually have. So our number sold is a total items minus the number that's spoiled, because those that spoiled or those that were stolen have no value. We can't make any money off of them. We can figure them out using amounts, which is the process that I'm going to be going through here today. There is also a way to figure them out using only percents, and I'm not entirely sure we're going to show that just because it's a time issue more than anything else. But if you would like to see that video, I can do a quick one on it and put it on as an extra added. Our selling price for perishable goods is listed as the expected selling price, or the money you expected to bring in, divided by the difference between the total quantity you have to sell minus the anticipated spoilage, or the reality of how many you have to make the money off of. So I would like to try a couple of problems. I'm realizing I say so an awful lot. Trying a problem to begin with. So Prestige purchases 460 pounds of sweet potatoes at 80 cents per pound. They have a 10% spoilage rate anticipated, meaning they're not sure they'll get that, but that's how much spoilage they think they'll get. At what price should the sweet potatoes be sold to achieve a 35% markup based on selling price? So a couple of key points. They've got 460 pounds of sweet potatoes. They're selling them at 80 cents per pound. I know there is a 10% spoilage rate anticipated, meaning I'm not entirely sure it will be a 10%, but that's the average. I know that it is a 35% markup based on selling price. So I'm going to need that, because the markup based on selling price and the markup based on cost are the two different ways I can figure this. This one is a markup based on selling price. Okay. So to begin with, we've got 460 pounds at 80 cents per pound. So we have spent, or Prestige has spent, $360 on sweet potatoes. They expect to get a total selling price with a 35% markup based on selling price. Since it's based on selling price, this will be a cost divided by the complement of the markup, or $368 divided by 65%. 368 divided by 0.65 is $566.15. This is the amount of money that they expect to bring in from all of their sweet potatoes. in order to cover the cost of their sweet potatoes and any markup, they expect to bring in $566.15. The problem is they won't have 460 pounds. The expectation is they're going to lose 10% of that 460 pounds to spoilage. Now, 10% of 460 is 46 pounds. So 46 of those pounds are going to be lost. We cannot count on them for sale. We cannot count on making money on them. So that means of the 460 pounds, there is only going to be 414 pounds left. So when we calculate our actual selling price for these pounds of sweet potatoes, we need to take the total selling price, the amount of money we expect to bring in, the $566.15, and we need to divide it by the number we will actually have to sell, which is 414. This gives us a 1.3675 or a final selling price of $1.37 per pound. Second example, Gigi's Bakery makes 250 cupcakes at a cost of $1.75 each. If you haven't tried Gigi's in Madison, they're fantastic, but you pay for the cupcakes. You'll see in a minute. They have a spoilage rate of 6% and a 225% markup based on cost. What is the selling price of these cupcakes? Now, notice this is a markup based on cost. This is a different formula than the 3 other times we've had to do this in this particular presentation. So, to start with, 250 cupcakes at $1.75 each means we have already put, or Gigi has already put, $437.50 into these cupcakes. Since they are using a 225% markup based on cost, that means an additional 225% markup outside of recouping 100% of their costs already. This gives us a $437.50 times 325%, or $437.50 times 3.25, or $1,421.875, or 0.88 if you're going to be rounding. This is the total amount of money that they need to bring in to cover the cost of the cupcakes and any markup. So the problem is that they're going to have a spoilage rate of 6%. Now, again, a spoilage rate of 6% does not mean that 6% will necessarily spoil. It means that 6% could be spoiled or lost, which, if I'm making 250 cupcakes, I'm going to assume that some of them are going to be lost to taste tests. So our spoilage is 6% of 250, and 6% of 250 is 15 cupcakes. That means 15 cupcakes will be lost and not be able to be sold because they're eaten. Maybe they didn't sell and they're dried up at the end of the night and they're just not sellable, but chances are a good portion of that 15 will be eaten by myself and my co-workers. So of the left to sell, we have 250 minus that 15, or 235 cupcakes left to sell. So our actual selling price is all of the money we expect to make, that's the $1,421,875, divided by the number of cupcakes that are left to sell, or 235. So $1,421,875 divided by 235 gives us $605. So our final selling price of the cupcakes should be $6.05 per cupcake. If she wants to make all of her markups, she should be selling each cupcake for $6.05. Does that seem unreasonable for a cupcake? You've never had Gigi's cupcakes. Yeah, I think they are about $6 a cupcake. They're a little bit bigger. They're not like the little cupcakes, but still. They're filled with great things, though. Third example, Door-flingers. Purchase 120 lipsticks from a distributor at a cost of $2.80 each. For those of you who are not familiar, Door-flingers was a department store where Duluth Trading Company is. My grandmother worked at Door-flingers. She was the cosmetics lady. She sold Estee Lauder, and I was the best smelling 3-year-old in the entire world. All right, so Door-flingers purchases 120 lipsticks from a distributor at a cost of $2.80 each. The markup on lipsticks is a 75% markup based on selling price. Shrink in the cosmetics department is some of the highest in the store at 20%. Determine the selling price of the lipsticks. So I don't know if 20% is reasonable, but I do know that the cosmetics department in any department store generally does have the highest amount of theft, simply because it's really easy to pocket cosmetics without anyone noticing. So we want to note that this is a markup based on selling price that will help us determine which formula to use. And then we want to find, first of all, the total cost of the items. So 120 lipsticks. Oh, why do I have 400? 120 lipsticks at $2.80 each is $11.20. Maybe I'll just switch it to 400. Hold up. I need to make these work. So I'm going to switch this pen. Yeah, we're going to make this 400. Because why wouldn't you buy 400 lipsticks? So we'll make that a 400 lipsticks. From a distributor cost. Okay, let's hope that this works. All right, so we're going to take $11.20 divided by the complement of 75%, which is 25%. $11.20 divided by 0.25 is $4,480. That's how much money they need to bring in to cover the initial cost of the lipsticks and the markup, $4,480. Now, the spoilage and or shrink is 20%. I made the right decision. So we need to expect to lose 20% of 400 or 80 lipsticks. That means 80 lipsticks are going to be lost to whatever reason, theft, inventory. Some 3-year-old smashed it into his face. And those 80 cannot be sold. That gives us 400 minus 80 or 320 lipsticks left to sell. Our actual selling price then is going to be the total amount of money we need to bring in. That's the 4,480 divided by the number left to sell, or 320. We're going to spread that evenly among the 320 we have left to sell, giving us a price of $14. So each lipstick should be $14. Couple of things here before I click off of this last example. No, $14 is not a lot of money for a lipstick. It's actually pretty reasonable. That's the first thing for those of you who are unfamiliar with lipstick prices. The second thing that I did want to mention is that if they don't lose all 20, or all 80, if they don't lose all 80 lipsticks, then every one of those 80 that they don't lose is just gravy. It's pure profit. So it's actually helpful to overestimate your spoilage. I mean, you don't want to overestimate it so you're pricing yourself out of an item, but you do want to be aware that overestimating your shrinkage or your spoilage means that anything that doesn't spoil is just pure gravy. It's just extra money in your pocket, right? I recognize that perishable items and shrink can be a little bit of a concept, and that the markups and markdowns in a series can also. The PowerPoint offers a couple of links, or offers a link to a few extra problems that you can do paper and pencil to practice. There is the worksheet itself and a key. These will both be available in the folder on Blackboard covering markdowns and perishables. And then we just want to go over whether or not you feel confident doing these things. Do you feel like you understand and can explain the purpose of a markdown? Can you calculate that markdown amount in percent? Can you find the selling price of an item after a markdown is taken? Meaning, can you find the sale or discount price? Do you feel confident in finding the price of a markdown if you're given, or finding the original price if you're given the amount of the markdown and the markdown percent? Do you think you can do it, find the original price, if you know the discounted price and the markdown percent? Do you feel fairly confident in calculating the final sale price after a series of marking up and marking down, whether it's markup based on cost or markup based on selling price? And lastly, do you feel like you can explain the process for perishables, calculating the selling price of perishable goods or goods that experience a lot of theft? Can you do so for markup based on cost and markup based on selling price? As with many of our assignments, there is extra practice in Chapter 8, Section 3 at the end of the section in the review exercises. I believe there are once again 24 problems to choose from. And this time I also know that there is extra practice in the physical copy of the book. We're looking at pages 250 and 252. They should be the end of chapter 8, section 3, the review exercises. Again, I just have page numbers if you have a physical copy. The graded assignment is on WebAssign. You will find it in the WebAssign homework, chapter 8, section 3. I did not name this one creatively either. As with your other assignments, if you have any questions or anything that you would like clarification on, please do not hesitate to reach out to your instructor, to our embedded math support personnel, to the Math Center, or to any of the tutors that you have available to you. Thank you.